Piecewise function is nothing more than a collection of pieces that make up one function. So what we're going to do with this graph is, or this function is, we're going to come up with a way of rewriting this. So most of you guys did something like this. Oh, there's my answer. Now let's go on to 27. And no, all right? But this does kind of help because you can spot a lot of things. You know, this is nothing more than a straight line going all the way down on both sides, right? And we can write an equation for the line that has a positive slope, that will be this one right here, and the line that has a negative slope, that will be this one here, right? So as long as you can recall the parent functions, this one will be a y equals x, and this one would be a y equals negative x, all right? Assuming that it goes all the way through. But we need to chop them, you know, we need to cut the bottom pieces. These pieces right here need to go away. So what we're going to do is we're going to restrict the domain on each one. We're going to chop this piece down and we're going to chop that one off, okay? So let's rewrite this function as a piecewise function. All right, so let's see. So we'll do, I'm going to write f of x because it's what we use mostly in calculus. So I'm going to say y equals, or f of x equals x. So this is my y equals x will be this line right here. And the one that has a negative slope, that would be y equals negative x. Now, so far right there, if I don't restrict the domains, I'll have the x. I'll have this line, the complete line. So I need to restrict the domains. Now, if I concentrate on this line over here, notice that you'll have to go from 0 all the way up to the right. So the domain will be from 0 to positive infinity, or you can say all x is bigger than 0, all right? So that's exactly what we're going to use, x bigger than 0. So the other one will be x is less than 0, right? At this stage, what you have is this. You have a gap in the center because notice that these two, neither of those has a equal in it. So you need to include. It makes no difference which one you choose. You can choose the one with the negative slope or the positive slope. As long as it's included, you'll be fine. So you just done a piecewise. This is equivalent to the absolute value function. That's all I want. For this problem, the kids were thinking, well, you know, in pre-cal I learned that, you know, the absolute value is the v, and then you have transformations. Maybe that negative x reflects over x. I can't recall. Maybe over y. And then the 5, maybe it moves 5 to the right or maybe 5 to the left. I just can't recall that. We're going to use the same strategies that we learned in problem 26. So let's go back to problem 26 and try to look for some patterns, right? Because in problem 27, assuming that you don't know what the graph looks like, we can still use the same strategy as problem 26. So how did I go from this little x to here? Well, didn't I just copy what was inside of the bars, basically, no, right? Well, yeah, but to go from here to here, didn't I just copy that little x right there, and boom, I put it there? Yeah. And then for the bottom piece, I just copy that, and I switch the sign. That's all I did, right? Now, this part right here is a little bit different. How did I get this 0 over here? Well, fortunately, we know what the graph looks like. Look what's happening at 0. That's where the two pieces connect. So this is what I call a breakpoint. Okay? That's where the two pieces break or they connect. All right? Now, how did I get that 0 without looking at the graph? With the graph, you can just look at it. But without looking at the graph, just looking at this right here, what you're going to do, you're going to set this inside portion and you're going to set it equal to 0. All the time. So whatever you see inside of the bars, you're going to set it equal to 0, and that's how you get your breakpoints. Your breakpoints are always going to be right here in your domain. Whatever numbers you see, if you see a 1, 1 right here, 1 and 1, then 1, in your head you should know that it's a breakpoint, and something is happening there. Functions are being connected. All right. So let's go to problem 27. 7, and we're going to rewrite this without even making any sketches, okay? So here we go. F of x equals, we're going to grab the inside, and we're going to just copy it on my first function. And remember, the second piece, it was the same thing, but we just switched the sign. So negative 5 minus x. And now I need to come up with the domains. Now here's where the thinking part comes in, right? You really have to analyze what this top function looks like first, right? So this is not hard because you saw this in algebra 1. This is y equals 5 minus x. So you're like, I'm not used to seeing it like that. So how about writing this as y equals minus x plus 5? The only thing I did is I switched them, right? No magic there. Can somebody tell me what the slope is in this line right here? Negative 1, and the y-intercept is 5. Booyah. So I can visualize this with my head. I'll stop. The top one should be for x is less than 5. So therefore, the one on the bottom should be for x is greater than 5. And one of them needs to have a equal sign. I'll do it on the bottom just to. There we go. So we just done problem number 27. If we want to sketch this, it would be nothing more than 2 lines with a breakpoint at 5. So we will have something, not quite that, but this. Okay?